Hey everyone, Sebastian here. Just introducing this video. It's a compilation walkthrough of Bluebook Test 1, Math Module 1. I've done these in bite-sized form, and now I've cut them all together so you can watch them without the intro and without the conclusion if you just want to grind through a whole module in one go. I know some people, their favorite part is the intro and the exit. So if you're like that, you can go back and watch the short videos. So you'll see that I'm cutting. I'm going to be changing clothes because these were shot on different days. Maybe there's a little bit of jarring cuts, but I'm human, just like you. I'm not a machine. That's what you like about it. So sit back, relax, watch them, take a break if you need. If you want, go back to the old videos, and I'll see you on the other side. So for this one, you should be able to do this one without any writing down, right? It's just about counting things. So frequency table, you have a number of something. So it could be like number of siblings, and then you have the frequency that some kids in the class have that sibling, right? So for this, it's just, there's no real data, world data to it. It's just numbers that they give us, right? And we have 4 4s, 3 8s, 2 13s, right? And just use the answer choices. So when you see 4 4s, you want to eliminate anything that doesn't have the number 4 with a frequency of 4, right? So this one has the number 4 frequency of 10. Goodbye to that one. This one has a frequency of 4 for number 10, frequency of 8 for 24. Goodbye to that one. And then you have this one here, frequency 4, number 4, so that one works. Frequency 4, number 4, so that one works, right? And then you have the 8s, right? So you have 3 8s, so you just want to be careful. The number 8 has a frequency of 3, right? This one has the number 3 have a frequency of 8. They reversed it. And then if you wanted to check your work right, you could check with the 13s. There's 2 13s, so the number 13 should have a frequency of 2. And that's how you do this one, right? On the test, it should take you 15 seconds, 20 seconds, and then it's giving you time to do the harder questions. Which expression is equivalent to x squared plus 3x minus 40, right? So what you do here when you have the answer choices is you have to just use them, I think is probably the best way. So we'll do that way. And then we'll do the way where you don't use answer choices. So has to multiply to negative 40. So they all do that, right? Negative 4 times 10 is negative 40, negative 5 times 8, negative 40, negative 8 times 5, negative 40, and negative 10 times 4, also negative 40, okay? So that doesn't help, but we want to have a difference, right, because it's plus and minus of 3. So which of these are 3 apart? It's not A, and it's not D, right? Those are 6 apart, so it's this one. And then how do you know which one is going to be the better choice? Is it plus 8 or plus 5? Well, since the middle number, right, is positive, we're going to go with a middle number where the bigger number is the positive one. So that's going to be B. Negative 5 and plus 8, right? So then I'm going to show you how that works. So let's see. All right, so you have, we foiled that, x minus 5, x plus 8, right? So x times x times plus 8, negative 5 times x, and negative 5 times positive 8. So x times x is x squared. Negative 5 times x is negative 5x. 8 times x is 8x. And then negative 5 times 8 is negative 40. And that gets us x squared plus 3x minus 40, which is exactly what we want, right? So that's one way you can do it. I think that's the best method. Fastest, easiest, no frills method, right? The other thing you could do is you could plug it in to Desmos, which I'm going to do right now. So we're going to do, okay, so then here we're going to do x squared, right, plus 3x minus 40, and then we see the solutions, right, at negative 8 and positive 5, and then the solutions are just the negative of what we have in the answer, so it would get us back to x plus 5, or x minus 5, x plus 8, okay? Okay, so then if you're going to do the quadratic equation, you're going to do negative b plus or minus square root of b squared minus 4ab C, and I'm going to show you why this one is just worse, right? Because there's so much more work all over 2A. Right, so I'm really doing this not to show you how to do it. I'm showing you why you shouldn't do it. So you're going to do 3 times, that goes in, right? So this is the A value, 1. This is the B value, 3. And this is the C value, negative 40. So then it's going to be negative 3 plus or minus square root of B squared, which is going to be just 9 minus 4 times A, so that's 4 times 1, which is 4 times negative 40, positive 160, all over 2A, which is just 2, and that's going to get us negative 3 plus or minus square root of 169, all over 2, which is negative 3 plus 13 all over 2, which equals negative 3 plus 13 is 10, divided by 2 is 5, which is the x minus 5, or the negative 3 minus 13. Right, so that will be all over 2, which equals negative 8. Right, which is the positive 8. So then we get back to this. But again, that's so much more work than just using the answer choices or factoring. You gotta love factoring on this test, okay? It's gonna be a huge lifesaver. And you can see that it'll factor easily because all your answer choices are nice whole numbers. If you saw that they weren't nice whole numbers, like they were 3.2 or 4.6 or something, then sure, use the quadratic equation. But honestly, if you're doing this, I would still rather use Desmos. I would go easily factoring. Then Desmos is right below, but still good. And then a distant third is the quadratic equation. A walks at a speed of 3 miles per hour and runs at a speed of 5 miles per hour. He walks for W hours and runs for R hours for a combined total of 14 miles. Which equation represents this situation? Okay, so it's a combined total, so you're doing the total of this walking and the total of the running. So the total of the walking, right, if we do distance, I'll change that color up here, not blue on blue, right? I want some red on blue, and I'll make it a little thicker. Okay. So we're going to have distance equals rate times time. Right? And they tell us W is the hours for walking. So that's going to be the T, and then the rate is 3. So it's going to be 3W, right? And then distance for the other one is going to be distance for running, let's say, and then this is distance for walking, is going to equal 5R, right? And then the total distance, they add up to 14 miles, and it's just going to be 3W plus 5R equals 14, which is going to be A. Okay? And that one's nice and straightforward. You just need to know D equals R times T, right? So sometimes people might get confused and you can plug in values to sort of make it more real to yourself, but you want to get it beyond that point for the test, right? You want to be more comfortable so you don't have to do that. Because if you did that here, let's say I say R is 2 hours, so that's 10, and then W, that would be 4/3 hours. The numbers aren't clean. Then you have to plug in here and there, so I wouldn't even bother showing you that method because it's just a really awful method that won't be useful to you. So in triangle ABC, the measure of angle B is 52 degrees, and the measure of angle C is 17 degrees. What is the measure of angle A? So we have a triangle, right? I could draw it out for you and just be like, okay, here's ABC, right? On the test, I wouldn't recommend that because you want to save time and it's really conceptual, so you don't need to do that. But then we're going to say angle C is 17, angle B is 52. Obviously, this is not proportional or very accurate to what it would look like with these angles, but just for concept, right? And then we're going to do 52 plus 17 plus A equals 180. So that means A equals 180 minus 52 plus 17 is 69. So it's going to be 180 minus 69. So A equals 111. Okay, so that one's nice and quick again. It is D. So again, you should be able to do this one 20, 30 seconds, maybe minimal writing and quickly, right? The graph represents the total charge in dollars by an electrician for X hours of work. The electrician charges a one-time fee plus an hourly rate. What is the best interpretation of the slope of the graph? So this is a straight line, right? They mentioned hourly rate. When you see that, you're thinking y equals mx plus b, right? So it's going to be y equals mx plus b is like our idea, right? And as a quick refresher, right, the b is the y-intercept, the m is the slope. So here we have no numbers, right? And it's asking what the slope is. The slope is the rate, right? Slope goes with, let me draw a bad arrow here, to the hourly rate. And this is like the initial fee. So we're going to do electrician's hourly rate, A, right? If it had asked for what the y-intercept is, that would be B, the one-time fee. The maximum amount, if it had like a cap, then we would do that one, but there's nothing there. And then D, the total amount that the electrician charges. That would be sort of any position here, right? Like at this number of hours, that would be his charge. But that's all we do, right? So like other videos I've done, this doesn't really have any numbers or math. It's very conceptual and very quick, right? On the test, you'd want to do 15 seconds. You read the question, you understand it, and then you move on. Here, the table summarizes the distribution of color and shape for 100 tiles of equal area. Okay, and then there's this table. If one of these tiles is selected at random, what is the probability of selecting a red tile? So first I just noticed there's no multiple choice here, right? It's when you do strictly off of the numbers, right? It's a fill in the blank one. So what is the probability of selecting a red tile? And here they don't give us anything, any type of limit, right? It's just all these. So let's go to red. We have 10, 20, 30. So it's going to be 30 out of 100, which is going to be 0.3, right? And they say not to express it as percent because you can't do that on the, well, you could put in just 30, but they want it as a probability. So you could do either 0.3 or 3 out of 10, okay? So it's pretty straightforward. If they had asked, what is the probability of a pentagon being red, you would do 20 out of 45, right? You could always make it more complicated, but here they went nice and straight. Just out of the total, how many were red, right? 30 out of 100. Okay. So from a population of 50,000 people, 1,000 were chosen at random and surveyed about a proposed piece of legislation. Based on the survey, it is estimated that 35% of people in the population support the legislation, with an associated margin of error of 3%. Based on these results, which of the following is a plausible value for the total number of people in the population who support the proposed legislation? Okay, so this one does have calculations, unlike some of the ones we've been doing. So, total number of people who support it, right? It's estimated at 35% out of 50,000. So you can do that like this: 35 out of 100 times 50,000, right? And then that's gonna be what, right? We're gonna do 100 divided by the 50,000 divided by 100. We cancel out the zero, so it's 500 times 35, which is gonna be around, let's do 5 times 35 right here. 5 times 5 is 25, carry the 2. 5 times 3 is 15, so it's around 175. So we have 17,500, right? So that's where we're going, and we have an associated margin of error of 3%. So 3% of 50,000 is going to be, anyone know? 1,500, right? So we're going to subtract 1,500 and add 1,500 to 1,500. So that'll be 17,500 minus 1,500 gets us 16,000. And then, let's do the other part. So we have 16,000 right now. And then the other one is going to be plus 17,500. That's too many zeros. Plus 1,500. It's going to be 19,000. Okay, so then we have that there. So it's going to be between 16,000 and 19,000. The only one that works right is C. Okay, and there's other ways to do this one. You could have subtracted the 32%, the 3% from 35%, and you would get 32%. And then added it and got 38%. And then do 32% times 50,000, which will get you 16,000. And then 38% times 50,000, right? Which will get you 19,000. The trick I do there, I don't know, I keep making my 9s into G's. The trick I do there, right, is when you're multiplying by 5, you're really dividing by 2 and then adding a 0. So when you're multiplying by 50,000, you're dividing by 2, so you get 19. And then you are adding multiple zeros, right? So then you're going to get 19. So that again would get you C. So you can use either one, whatever you feel comfortable with, whatever comes into your head more naturally, all right? What is the positive solution to the given equation? Okay, so we have, again, no answer choices, right? Like I think a couple questions ago it was like that. And you can do this simply by multiplying out. So I'm going to multiply by x plus 6 on both sides, and I'm going to get 55 equals x times x plus 6. And then I'm going to distribute and get 55 equals x squared plus 6x. Then I'm going to subtract 55, right? So we're going to have x squared plus 6x minus 55. Okay, so what's that going to be for us? Boom, boom, boom. I'm going to erase. Okay. X squared plus 6x minus 55. I'm going to factor, right? So there's two ways you could do it. You could do Desmos, which I'm not going to do today because I really just think you should factor. But if you need to, you could put it into the calculator on Desmos, see where they match, and go to the positive solution. So then here we're going to get x minus something, and x plus something, right? Because it's a minus sign here. So the plus is going to be bigger because it's a plus 6. So what has a difference of 6 and has a multiplication of 5, 55 multiplication, I mean product, right? It's going to be 5 and 11. So it's going to be x minus 5, and this equals 0, right? And then x plus 11 equals 0, and then x equals 5 and negative 11. And it asks for the positive solution, right? So we're going to just go with 5. Okay, you know what? I am going to do Desmos just because I'm feeling cheery. Okay, so here we're going to do x squared plus 6x, whoops, plus 6x minus 55, right? You just plug it in there and you're going to get that it equals 5, okay? And if you scrolled over, right, you would get this one here, a negative 11, all right? So then if we go back to the question, and again, with the graph, you get 5. An airplane descends from an altitude of 9,500 feet to 5,000 feet at a constant rate of 400 feet per minute. What type of function best models the relationship between the descending airplane's altitude and time? So looking at our answer choices, right, we have decreasing exponential, decreasing linear, increasing exponential, decreasing, increasing linear, right? So it's going 400 feet per minute, so that means it's linear, not exponential. It's not rising or decreasing at a variable rate. And then we're going from 9,500 to 5,000, so it is decreasing linear, right? Nice and simple. With this, I like to break it down using the answer choices. So I focus first on the exponential versus linear. You could have focused on the decreasing versus increasing first, and then I focus on the other part. And obviously, you can get it intuitively, just be like, oh, of course, this is descending linear, but if we're breaking it down step by step, this is the way I do it. So the given function g is graphed in the xy plane, where y equals g of x. What is the y-intercept of the graph? Okay, so, and then the equation is g of x equals 11 times 1/12 x. Okay. So here, right, we have this. What is the y-intercept? Y-intercept is when x equals 0, as we can see in all the answer choices, right? 0, 11, 0, 1, 32, 0, 1, and 0, 12. So you can just plug in 0 up here. And we're going to get 11 times 1/12 to the 0. 1/12 to the 0, anything to the 0 power is just 1. So it's 11 times 1, which is 11. So that's going to get us A, right? And if you got frozen on it for some reason, you could plug it into Desmos and find it. I'm not going to do that. And just remember, anything to the 0 power is 1. Anything to the 1 power is itself. Okay. And as you see, it has to do with a circle, has some intersections going. You know, it's a very exciting one. I love it when there's images. It sort of mixes it up. It's not just words and numbers the whole time, right? So the circle shown has a center O, circumference 144 pi, and the diameters PR and QS. The length of arc PS is twice the length of arc PQ. What is the length of arc QR? Okay, so here, the length of arc QR is what we're looking for. Diameters, so that the diameter part just tells us that this meets exactly in the center, which is important, otherwise it wouldn't work as easily. The length of arc PS is twice the length of arc PQ, so let's call this 2x. And this one will be just x, right? What is the length of arc QR? So if the 144 is the whole circumference, then we do 144 pi equals, then we have 2x, x, that's half, so that's going to be 2x plus x, and let's say we're going to double that, right? So that's going to give us 144 pi equals 6x, right? Because 2x plus x is 3x, you double it. So then x equals 144 pi divided by pi. And look at the answers, right? They're all written with pi, so I'm not going to bother multiplying it out, right? Always look at the answers to know exactly what's expected of you. 144 divided by 6 is 24 pi. Okay, so that is x, and we're looking for QR, which is 2x. So QR equals 2x because it's the same as SP. Right? We know that because these are vertical angles, so they're the same central angle. Same central angle would have same arc length, right? So QR equals 2x equals 2 times 24 pi, and that equals 48 pi, right? Again, this type of stuff you don't really need to write out. If you can do it in your head, that's great. It's not too bad. So then we're going to go with B, right? I think the most common mistake people do is they do A. But if you can do it like this, then it works out, right? So I think this is the first circle question we've done on this test, and it's not that bad. All right, a rectangle has a length of x units and a width of x minus 15 units. The rectangle has an area of 76 square units. What is the value of x? Okay, so the rectangle is an area of 76 square units. All right, so let's imagine a theoretical rectangle, right? Let's say our ideal rectangle, right? I don't know about you guys, but my ideal rectangle is always longer sideways than it is up and down. This has nothing to do with the math. I don't know why it's like that. So that means this is x. This is x minus 15. Again, don't need to write this out just because I'm writing it out. I'm doing this so that people who maybe are confused have more to look at. So this is the area. Area of a rectangle is the two numbers multiplied together, right? The two dimensions. So we're going to have x times x minus 15 equals 76, right? Okay, so now we're going to get, when we distribute x squared minus 15x equals 76. We're going to add 76 to both sides. We're going to get x squared minus 15x minus 76 equals 0. And then that's going to give us, when we factor, right, x minus something that multiplies to 76 has a difference of 15, right? Does anyone know? Testing, testing. All right, so it's going to be 19 and 4. So x minus 19 times x plus 4 equals 0. So then x equals 19 and negative 4, which equals 0. Oh, wait. That's just what x equals, 19 and negative 4. Negative 4 cannot be possible, right? Because dimensions that we work with are positive. So x is 19, and that is all it's asking for, right? Nice and clean. It could have been tricky, could have asked for the width, and that would have been a, but it didn't. It was nice and clean. Okay, so that is our answer for this one. If you wanted to, you could plug this into Desmos, right? You just plug in this equation, x squared minus 15x minus 76 equals 0, and you find it. But if you can do it without Desmos, that is great. So this one has a nice chart, right, which is going to be fun to work with. Rosa opened a savings account at a bank. The table shows the exponential relationship between the time t in years since Rosa opened the account and the total amount n in dollars in the account. Rosa made no additional deposits or withdrawals. Which of the following equations best represents the relationship between t and n? Okay, so we want to see the relationship between those two values. So we're going to find it, right? Rosa opened the account for a total amount of n dollars. So when she opened it, it was at 604, right? Because that's the initial amount, and then it goes up. Okay, so just looking at the answer choices, because it's going to be really simple when you do this, is we want to start when we have 0, which of these goes us 604, right? And then this one gives us 1 when we plug in 0. This one gives us 1 when we plug in 0. This one gives us 0.004 when we plug in 0, and this one gives us 604 when we plug in 0. Why? Right? Because anything to the 0 power is 1. So when we plug in 0 here, this times 0 becomes 1. When we plug in 0 here, 1. When we plug in 0 here, we get 604 to the 1.004 to the 0 power, and that gets us 604. Wow, so see that? That's going to be C. So that's the only one that's going to work, because the next one is going to give us 0.004, which we don't want. So the only answer that works is C. It's also the only one that works, because if we look here, it goes up a little bit, right? $2.42 from 604. The other ones, this here would go up an insane amount. 605 to the T would be multiplying by 605 every time you go up 1. This one goes up the right amount, but it doesn't have the initial value that we want here, right? And then the bottom one goes up an insane amount and has this thing that flipped, right? So just remember when you're thinking about interest rate and things like that, the amount is equal to the principal times 1 plus the rate to the time, right? And it can get more complicated depending on how often you're compounding. If your rate, you can break it up by doing like annual rate divided by 12 if it's monthly, to the times the years times 12 and things like that. But this is the basic level, and that's all you need for this one, right? And you don't even need to know that formula if you just work it through with like number sense and understanding. At how many points do the graphs of the equations y equals x plus 20 and y equals 8x intersect in the xy plane? All right, let's think about this, right? There's two lines. Do they intersect? Do they not? That's the mystery. So there's 3 ways that lines can intersect when they're both straight lines. You can have them be the same line, and that would be infinite, right? Infinite equals same line. You can have them be parallel and never intersect, so that'd be 0, parallel. Or you can have them be 2 different lines that aren't parallel. Everything else in existence is going to be one intersection. One intersection. And what is this asking for, right? It's asking for how often they intersect. It's not asking for where they intersect. It's not asking for the x value or the y value there. 1. So this one is going to be 1 intersection. Okay, and you can graph this on Desmos. I'm not going to do that because I don't want you to do that for this question. I want you just to know this fact. If you plug it in and solve, you'll see they intersect. It'll be beautiful. It'll be lovely. But don't do that. Know this. Trust yourself that you know this. 5G plus 45R equals 380. At a school fair, students can win colored tokens that are worth a different number of points depending on the color. One student won G green tokens and R red tokens worth a total of 380 points. The given equation represents the situation. How many more points is a red token worth than a green token? So if this is going to be 5G plus 45R equals 380, right? So this is the total points. So to find total points, it's sort of like rate equals R, not this R, but a different R. The concept of rate, which is not what I want, right? It's D equals rate times time. It's something like that, right? It's like total equals a number versus by value. So if G is the number of green tokens and R is the number of red tokens, then the 5 is the value of the G. 5 equals value of green. Green, right? 5 equals the value of green. And 45 equals the value of red. And what's 45 minus 5? Don't pick up that calculator. You know, do it straight in your head. 40, right? Trust yourself. You got that mind. And if you really need to, I guess you can plug it in. But 45 minus 5 equals 40. All right, great. All right, question 16. The number of bacteria in a liquid medium doubles every day. There are 44,000 bacteria in the liquid medium at the start of an observation. Which represents the number of bacteria Y in the liquid medium T days after the start of the observation? Okay, so it is doubling every day. Okay, why is it always doubling? You know, why is it never tripling or 1.5ing? Sometimes, but doubling comes up a lot. 44,000 bacteria at the start, right? So this is similar to the one we did a couple days ago with the bank stuff. So 44,000 should be the initial amount. Doubling is the amount that's going to be taken to the power, so it's going to be 2. And then T is the number of days, right? So this is exponential growth. So if we were to graph something like this, no, we don't need Desmos for this. We just need to imagine it. It's like this, boom, right? It's just going to explode in growth. But it's not going to start really close to 0. No, it's going to start at 44,000. So unless this chart is really weird proportions, it's not very accurate. But you understand what I mean. So 44,000 bacteria, okay? Which of these is that where you start when you put 0 in? When you put a 0 in here, you get 1/2 for T, right? When you plug in 0 for T, you get 1/2. When you plug in 0 for T here, you get 2. When you plug in 0 for here, you get 44,000. Okay, that's what we're looking for because that's the initial value, right? And when you plug in 0 for the last one, what are you going to get? Also 44,000. But the difference between them, right, is this one's halving every time and this one is doubling. So I love it. The answer is D. So a cylinder has a diameter of 8 inches and a height of 12 inches. What is the volume in cubic inches of the cylinder? Okay, so this one is pretty straightforward if you know the formula for the cylinder. And what does a cylinder look like, Sebastian? Oh, I'll draw it out beautifully. I'll do a Michelangelo impression here. Exactly, this is just how he drew them too. So it is circular base and then a perpendicular sort of height, right? So it's not a pyramid where you're going like this, it's going straight up. And whenever you have a shape like that, rectangular prism, triangular prism, circular prism, which I guess is a cylinder, it's area of the base times the height. And what's the area of the base, Sebastian? Oh, the area of the base is pi r squared, right? Because that's the area of a circle, times the height. So we have diameter. You want to be careful. This thing will throw you off if you're not careful because you'll think radius. You want to divide that by 2, right? R equals 8 over 2. That's going to give us R equals 4. So then area equals 4 squared pi times the height, which is 12. Okay. And that's going to give us A equals 4 squared 16 times 12. So we have 16 pi times 12. 16 times 12, anybody? Anybody? Yeah, 192, right? The way I did that was I know 16 times, or yeah, 16 times 6 is 96, and then I just doubled it. But if you don't know that, that's what the calculator is for. And remember, look at all your answer choices before. I looked at them, I glanced, it was a quick glance, and I saw, oh, pi, pi, pi. I don't have to do the multiplication of pi. So save yourself a step, save yourself a headache, and just circle C, right? So I think the biggest issue people would have is they would choose D by not noticing that it's 8 inches for the diameter. They would think it was 8 inches for the radius. And this is one of my favorite types of questions. It is a question on system of equations, right? So there's a couple ways to do this one. We can do it with regular algebra, out on paper math, and we can do Desmos, right? So I'm going to show you both ways, and then we'll go from there. 6x plus 7y equals 28. 2x plus 2y equals 10. The solution to the given system of equations above is xy. What is the value of y? So if I'm going to do it just out on paper, right, I'm going to do 6x plus 7y equals 28. And then I'm going to triple the second equation so that the 6x's will cancel. So I'm going to multiply it by negative 3 to add that. So then that's going to give me negative 6x minus 6y equals negative 30. That's going to get you y equals negative 2. And you just want to be careful to make sure you're answering what they want. Luckily, this time the one we solve for is the one they want, right? Y equals negative 2. So we're going to go with A. And again, you could look at the answer choices and see they're all whole numbers. So it shouldn't be too crazy if we did it this way. Now I'm going to show you how to do it with Desmos. All right, so now we're back. I'm going to do it on Desmos, right? Whoops, I'm going to close my Wordle. If you guys do Wordle, you're probably better at it than I am. I'm usually getting 4s, 5s, some 3s, but got a 2 recently. Was pretty thrilled with that. But okay, so then here, right, we're going to plug in the equations, right? Which are, let's just look back at them, 6x plus 7y and equals 28, and 2x plus 2y equals 10. Okay, great. So then that's going to give us 6x plus 7y equals 28, 2x plus 2y equals 10. 6x plus 7y equals 28, 2x plus 2y equals 10. The 2x plus 2y I could have also simplified and then solved it, but I didn't. So look here where they intersect. The y value is negative 2, x is 7, which is what we got on paper. For a lot of people, this is faster, so if you feel comfortable doing it this way, go for it. This one is in triangle JKL. Cosine K equals 24 over 51, and angle J is a right angle. What is the value of cosine L? With these, I really like to draw them out, right? So I'm going to do another Michelangelo impression. Maybe this time I'm Leonardo da Vinci. All right, I'm sure he drew nice triangles too. So it's like this. And we're told angle J is the right angle. That's the important part. Then we can say this is K and then L, right? Cosine is just telling us the ratio, but that's all we need because we're just looking for cosine of L. So what we'll do, I'm just going to write this out to remind you. So, well, I'm going to do it vertical. So there's you got sine, means opposite over hypotenuse, right? And then you got ka, which is cosine, which is adjacent over hypotenuse, which is what we're dealing with in this question. And then we got toa. I'm going to probably be writing this out on every question like this, so if you're watching them along, you'll probably get tired of this, but it's really going to be helpful when you have this be automatic and you don't have to spend a few seconds thinking about it. It's adjacent underneath opposite, right? So cosine of K is going to be adjacent to 24, and we have hypotenuse of 51. Okay, if we had answer choices, that would be helpful because then we wouldn't even have to do the math. But what we're going to do here, right, is find the other angle here. How do you do that, right? Well, cosine L is what we're looking for. We don't actually need to find that angle. We just need to find this side. That's how I'm going to do it. So I'm going to do 24 squared plus x squared equals 51 squared. Okay. Now 24 squared, I don't know that one. I know 25 squared is 625. And then I could subtract 49 to find it, right? It's 576, so I guess I do know it, but it's not automatic, so I'm going to do a calculator just to make sure. Yep, 576. And then 51 squared, right? 50 squared is 2500. 51 squared is going to be, is 2601, right? And then we're going to subtract that, so we're going to get x squared equals, okay, so we can do 2601 minus 576, which is going to be 2025, right? So 2601 minus 576, whoops, 2025. Okay, and then 2025, the square root of that is going to be this one. I did know, actually, it's going to be 45. So that is this value here. Of course, you could do this on Desmos, so it'll be pretty quick. And now cosine L, if you notice, right, cosine L is across from it, so it's going to be here. Adjacent 45 over 51. Ba-dum. So we're going to do this one two ways. We're going to do it once with paper, or, you know, the screen, the digital screen, this beautiful backdrop I have going for me. And once with, you guessed it, our favorite handy dandy calculator, Desmos. Okay? So, how do we do this? How do we do this question, right? So we have 4x squared minus 50x plus 126. And to tell us the given equation defines the function f. For what value of x does f of x reach its minimum? So it is quadratic because it's x squared, right? And it has a minimum because it faces up, right? If it was facing down, it would have a maximum. So it's something like this, boom, boom, right? So how do we find the x value at the minimum? We find the x value at the vertex, right? And to find the x value at vertex, we'll just call this x at vert is going to be negative b over 2a. And how do we do that, right? We have a is the one with x squared, b is the one that goes with x, don't forget the negative there, and c is the one on its own. So we're going to do negative b, so it's going to be negative 50, all over, you guessed it, 2a, so it's going to be all over 2 times 4, okay? And that's going to get us 50 over 4, or sorry, 50 over 2 times 4 is 8. And we can simplify that to 25 over 4, or 6.25, okay? And now you're thinking, Sebastian, I don't like doing the alphabet when I'm doing math. Let's save that for the verbal, and I totally get that. So we can forget this, right? Let's say you didn't know this formula, or you forgot it, you were frozen, or you thought you had a faster way to do it. What can we do? We can do Desmos, right? So on Desmos, all we need to do is plug the equation in and move it over and see where it is that we have the vertex, right? So let's do that here. I'm just going to erase what I have, and it's going to be clear drawing, right? So now we're going to go here. We go here, we have the equation of 4x squared minus 50x plus 126. So it's going to be 4x squared minus 50x plus 126. Okay, I'm going to make this a little bigger for you all. Let's see, so we want to go to the vertex, here it is, and there it is, right? So we have 6.25, negative 30.25, and 6.25 is the x value, which is what we got. So again, we got our answer, 6.25. All right, so I hope that helps you with this question, right? If you forget what vertex is, I think that's really where it throws you off. If you forget that you can use Desmos, that can make it complicated. And of course, if you forget that, and also that you can use negative b over 2a, then you might be in some trouble. But the good thing is you just watched this video, and you're not going to forget that now. You have it. It's in your brain. So this one, in the xy plane, the line L passes through the point 0, 0, and is parallel to the line represented by the equation y equals 8x plus 2. If line L also passes through the point 3D, what is the value of D? So if it's parallel, that means they have the same slope. Okay. So, and then we have y equals 8x plus b, but b is going to equal 0 because the y-intercept is 0, right? So b equals 0. So then we just have y equals 8x, okay? And then we just plug in, we're looking for d, so that's what is y when x is 3. So we're going to do y equals 8 parentheses 3. And that gets us 24. Easy peasy. Systems of equations, easy for us here. All right, and now if you have any questions on this, let me know. If you have a different way of doing this, I'd love to see it. I think this is the best way, but hey, I'm willing to be proven wrong. So I'm going to do it two ways. The Desmos way, which I think is probably the faster way. And then I'm going to do it without Desmos, if you feel comfortable with that. So in the xy plane, align with equation 2y equals c for some constant. C intersects a parabola at exactly one point. If that parabola has equation y equals negative 2x squared plus 9x, what is the value of c? So the key here is that this line's equation, right, has y equal a constant. So if I graphed it, right, it would be some sort of, that's the chart, it'd be a horizontal line, or horizontal line there. For that to happen, and for it to intersect the parabola just once, it has to intersect it at the vertex. Because that would be something like this, look. Boom. We would have something like this. And then there'd be a horizontal line. If it goes anywhere else, see there, I kind of messed up. If it goes anywhere else, it has two intersections or no intersections. For it to be exactly one point, it has to be like that. Again, kind of messed up, but the calculator won't mess up. So we just need to find the equation, the value of the vertex here, the y value. And then c is just double that. Okay, so let's go to Desmos. We'll plug it in, and then we'll go from there. Negative, oh, I already started. Lovely. Okay, so we're going to do negative 2x squared. Let's see. 2x squared plus 9x. Okay, there we have it. The vertex value is 10.125. That's the y value. And remember, we're looking for the y value. So y equals 10.125. Great, so we're going to put that in here. C equals 2y. I don't know why I went out like that. Okay, C equals 2y. C equals 2 times 10.125. C equals 20.25. Okay, and that is our answer. It's nice and easy. Let's say you don't want to use Desmos. Let's say you want to do it the old-fashioned way, right? That will be not too bad either. We find the x value at the vertex by doing negative b over 2a. Negative b over 2a is going to be negative 9 over negative 4. Okay, and we plug that into the calculator. Or plug it into the equation, I mean. So we're going to do negative 2 parentheses. Negative 9 over negative 4 is just 9 over 4. 9 over 4 squared plus 9, and then x is going to be 9 over 4 again. So 9 over 4 squared is going to give us, right, 36, let's see, oh no, 81 over 16, so it's going to be negative 1, 81 over, oops, negative 162 because I'm multiplying by 2 over 16 plus 81 over 4. So I'm going to quadruple this, right? And that's going to give me 324 over 16, which is exactly double that. So we're going to get back to positive 162 over 16, which equals 10.125 like we had before. And then again, we plug it in here. We're back to where we started when we did it with Desmos. We do it like this. Okay, so Desmos probably faster, probably better for 95% of you out there. 90%. I don't want to generalize too much. But if you don't want to do it that way or you freeze up on it, do it this way and it works out totally fine. But again, I really think Desmos is the key here. All right. All right, and that's our show for today, right? All Math Module 1 from Bluebook Test 1 in one easy go. If you have any questions on those questions, let me know. And remember to like and subscribe. I'm doing Bluebook 1 Math Module 2B, the harder section right now, and I'm going to do 2A next, and then I'm going to do the verbal, and then I'm going to do the other Bluebook tests. It's going to be all there for you. All right, and if you have any questions, you know what to do. Bye.